Hot dip galvanizing is a corrosion protection coating applied to steel fabrications by immersion in molten zinc. Metallurgically bonded to the steel, it provides one of the most robust coatings available, displaying outstanding sacrificial defense against corrosion and good resistance to impact damage. The immersion process coats every inch of the metal, including the inside and hollow sections, offering superior protection, with a maintenance-free life of at least 50 years, all with a quality and cost efficiency that paint-based systems cannot compete with. In addition, hot dip galvanizing is a low environmental impact solution, using less energy than an equivalent paint coating. The byproducts of the process are recycled and reused in various other industries, and when the steel eventually reaches the end of its useful life, the zinc can be removed and both metals can be used again. For cost-effective, tough and durable corrosion resistance, look no further than hot dip galvanizing. Protection that lasts a lifetime. The quality of galvanizing is largely dependent on the design and fabrication of the steelwork. Spending a small amount of time to get this right will pay dividends and help ensure a great job. As steel is only slightly denser than zinc, even a small amount of trapped air inside a fabrication will make it float. If it floats, it cannot be galvanized. No other coating can protect the inside of hollow sections like galvanizing, but this requires all air to be expelled from the fabrication. Adequate vent and drain holes to let the air out and liquids in are essential. We cannot avoid galvanizing the inside, but the result is total protection. This need for venting and draining must start at the design stage and generally follows well understood industry standards. In order to process the material, it must be suspended. This is achieved by using wires, hooks or jigs. Venting and draining holes can often be used for this purpose. The galvanizer will, whenever possible, attempt to suspend the material at an angle of 30 degrees to ensure all the zinc runs off, leaving a smooth finish. The zinc in the bath is heated to 450 degrees Celsius. At the galvanizing temperature, steel expands, so fabrications with thick and thin sections welded together might be subject to distortion due to differential expansion and contraction. There is almost always a way to design this out, but this requires discussion before fabrication. Specifying galvanizing is easy. Just ask for ISO 1461, the standard for the process. Galvanize your thoughts and think design for protection that lasts a lifetime. Once the steelwork has been properly designed and fabricated, it is ready for the factory-controlled process of galvanizing. The job will be booked in and the quantities and paperwork checked. The steelwork will then be wired for suspension and thoroughly inspected for venting and draining holes and any other issues that may affect the process. The secret to achieving a good quality coating lies in the preparation of the surface. It is essential that the steelwork is free of grease, dirt, scale and rust before galvanizing. These types of contamination are removed by a 5-stage pre-treatment process. Initially, the metal is dipped in a degreasing solution to remove any surface contamination. It is then pickled in a dilute hydrochloric acid which removes any rust or scale. This process on average takes 1 to 2 hours, but can take longer if the steel has a heavy layer of rust. It is then rinsed to remove acid residues before being dipped in a flux solution which is heated to 70 degrees Celsius. This fluxing leaves dissolved salts on the surface of the metal, which helps to wet the steel components with zinc, improving the quality of the coating. The last stage in pre-treatment is to dry the steel in preparation for immersion in the zinc. The steel is lowered slowly into the kettle of molten zinc, which is heated to 450 degrees Celsius. The resulting metallurgical reaction creates an alloy on the surface, forming a corrosion protection layer on the steel. The small explosions are created by very small amounts of moisture rapidly evaporating. The length of time in the zinc bath depends on how long it takes to sink hollow sections. Items with small holes will take a longer time, and this can affect the smoothness of the coating. The steel is then passivated to aid the prevention of storage stains on the product. Once the steel is at a safe temperature for handling, the suspension wires are cut and the fabrication is fettled, a manual process to remove any spikes of zinc. It is then thoroughly inspected and all items are checked and accounted for. The order is reassembled into the delivery batch it arrived in and is ready for collection.